All right, we're 1/3 of the way through the semester. During this module, we're going to be talking more about functional analysis. In this case, how we can adapt the traditional functional analysis methods to be more likely to be used in environments like classrooms or workplaces, or when you have limited resources, or simply when your initial functional analysis doesn't give you clear results. Part of the assigned reading for this module is in the form of empirical articles in the field of behavior analysis. As such, we're going to start by reviewing a summary of each article such that you can focus in on the most important information for the prep guide questions. As you should remember from measurement and research methods, these are the components of an empirical article that you should always consider if you wish to summarize that article or assess whether the results of the study are indeed valid and useful. The experimental question, setting, materials, and participants, the dependent variable and how it's measured, the independent variable and how it's manipulated in the methods section, the results, and the implications. First, the experimental question in Anderson and Long study. How do the results of a structured descriptive assessment compare to those of an analog functional analysis? Are the results of structured descriptive assessments valid? The authors provide a defense of when a functional analysis may not be feasible, and so wish to investigate whether a structured descriptive assessment will address these concerns and still be useful in identifying the function of behavior, and then effective intervention. It's important to note the setting, materials, and participants of a study in order to determine whether the study was conducted in a way that would allow you to generalize the results from that study to your own practice. Are your clients similar to those in the study in terms of diagnosis and history? Are you able to set up your environment in a similar way? In this study, the functional analysis was conducted in a controlled environment in the form of a therapy room with a one-way window, and the structured descriptive assessment was conducted in each participant's own home or classroom. The authors usefully noted that preferred stimuli for use in the play and tangible conditions were identified via assessment with the participants' caregivers. They should never be selected arbitrarily. Similarly, you should select demands based on indirect and direct assessment as well. The 4 participants in this study were aged 6 to 13 and diagnosed with various developmental disabilities. Various dependent variables were measured in this study, including self-injurious behavior, aggression, and disruption. The important thing to note is how they were measured. In this case, continuous frequency recording. The authors also calculated conditional probabilities from the structured descriptive assessment, which we'll review during the workshop. Typically, you don't need to focus too much on inter-observer agreement when reviewing a study. Just be sure to determine whether IOA data were collected in the first place and whether scores were high enough to indicate believability. We are in good shape with this study. The multiple observers had consistently high reliability between each other. Note that the authors also provide information about data collected on the therapists, teachers, and parents' behaviors in the section titled Response Definitions, Data Collection, and Inter-Observer Agreement. This is important as well as it pertains to treatment integrity, ensuring that the procedures were actually conducted correctly. If it was discovered in this study that structured descriptive assessments were not useful, but treatment integrity data indicated that the structured descriptive assessment was not conducted correctly, we wouldn't necessarily trust the results. As we determined with the experimental question, the authors in this study are comparing the structured descriptive assessment with the functional analysis. That is what's being manipulated across the different parts of the study. In each case, sessions were 10 minutes long. The functional analysis used a multi-element design with conditions of attention, task, also known as demand, and play, the control condition. Some participants also experienced tangible and alone conditions based on whether the authors thought those tests were relevant given the indirect and direct assessment results. During the structured descriptive assessment, sessions were conducted throughout the day whenever the appropriate conditions arose. Those conditions were attention, task, tangible, and play. Ultimately, there was correspondence between the 2 assessments for 3 of the 4 participants. Not bad, but not perfect either. The primary advantage here with the structured descriptive assessment is that participants don't need to be removed from their school or home environments in order to conduct a structured descriptive assessment. But this also means that the results can be less clear or, in worst-case scenarios, invalid. You aren't fully controlling conditions, but instead are capturing them as they occur during a typical routine. For example, in the case of prompts being given to Drew during the play condition, that's not perfect control, and in fact evoked the target behavior since it was similar to a demand. A structured descriptive assessment can clearly be very useful if you face concerns about removing a participant from their daily routine to conduct functional analysis, but keep Mitch's results in mind. The function identified by his functional analysis and structured descriptive assessment were completely different. Both assessments provided a clear result, and we would have no way of knowing which was correct until we attempted to intervene based on one or both potential functions. Now let's move on to the article by Bloom et al., in which they compared a trial-based functional analysis to a traditional functional analysis. This type of functional analysis has potential benefits similar to those of the structured descriptive assessment. It can be run in the participant's natural environment rather than requiring isolation. While in a structured descriptive assessment you would wait for the appropriate conditions to occur in the participant's typical routine, in a trial-based functional analysis you do deliberately manipulate the antecedents and consequences. But before we jump to use this useful adaptation, we need to ensure that it actually produces valid results. Again, we should briefly review the setting, materials, and participants. Similar to Anderson and Long's study, traditional functional analyses were conducted in a controlled session room, and trial-based functional analyses were conducted in each participant's own classroom. Preferred stimuli were identified based on direct assessment. 10 students aged 6 to 18 with a variety of diagnoses participated in this study. What we're again concerned with is how data were collected. In this study, continuous frequency data were collected only in the traditional functional analysis. In the trial-based functional analysis, partial interval data were collected in 2-minute intervals, along with the latency to the first response in each condition. Inter-observer agreement was high, so the results are believable in that sense. Treatment integrity was again described under response definition and reliability. Interestingly, the trial-based functional analyses were conducted with graduate students rather than the participants' actual teachers, which was intended to help with treatment integrity. But as a result, the treatment integrity and results of the trial-based FAs in this study might not reflect how things would happen in real life. In this study's traditional functional analysis, the authors alternated conditions of attention, tangible, demand, alone or ignore, and play, again in a multi-element design. One participant also experienced a pairwise design, which we'll review later. The trial-based functional analysis included conditions of attention, demand, and control for all participants, and tangible and ignore conditions only for some participants. For each session, participants experienced a control condition immediately followed by a test condition, then another control condition. The way in which the authors set up these test conditions in the study was really very clever. By presenting the control condition first each time, they helped to ensure a baseline period during which the target behavior ideally shouldn't have occurred. Then the test condition suddenly began. This means that stimulus conditions changed abruptly and noticeably, which should help to evoke and occasion the target behavior. By following that up with another control condition, the authors helped to show that the occurrence of the target behavior during the test was actually because of the test. Remember how functional relations are shown with the reversal design. They also hopefully abated the behavior from continuing to occur during the transition back to the participant's usual routine. Overall, the results of the trial-based functional analysis matched those of the traditional functional analysis for 6 out of 10 participants. There was partial correspondence for one additional participant. So, what might explain the cases in which the results didn't correspond? For example, in Sammy's case of partial correspondence, the trial-based functional analysis identified one, but not all functions of the target behavior. It simply wasn't thorough and long-lasting enough to get fully differentiated results. In Conrad's case, the target behavior was barely evoked or occasioned at all during the trial-based functional analysis. The SDs and motivating operations either weren't strong enough during these shorter sessions or, as proposed by the authors, the teacher may have actually been an S delta, since she had intervened on the behavior in the past. In the end, as with the structured descriptive assessment, trial-based functional analyses may be useful when full functional analyses aren't feasible. However, they're not perfectly reliable. the authors explicitly state on page 29 that trial-based functional analysis is not a replacement for the standard functional analysis. Also keep in mind that while the sessions are shorter than those of a traditional functional analysis, the trial-based functional analysis can actually be more time-consuming because it can take longer to get clear differentiated results. You also can't run the sessions quickly back-to-back, but instead have to wait for appropriate conditions in the natural environment. Now we'll move on to the article by Iwata and Dozier. What I'd like to focus on in this review is the list of functional analysis adaptations that the authors summarize. They provide very useful visual references for each one. First, we have the traditional multi-element design. This is not an adaptation, but is rather considered the classic way to run a functional analysis. Do note, however, that, as we've discussed, the conditions should be based on the contingencies observed in the participant's actual environment. You might not necessarily have to run each type of test condition, and even if you do, you would want to adapt the specific demands and type of attention delivered based on what you observe. Reversal and pairwise designs, pairwise to be displayed on the next graph, are used when you don't get differentiated results from a multi-element design. As covered in measurement and research methods, sometimes the conditions of a multi-element design alternate too rapidly for stimulus control to develop. A reversal design in which you wait for steady-state responding allows that stimulus control to come into effect. This is more time-consuming, so you wouldn't want to start with this design, but it is useful if you're unsure of the function of a behavior based on the initial multi-element design. Here is the pairwise design. Instead of waiting for steady-state responding in a reversal design, you instead alternate rapidly, as you would with a multi-element design, but only between a single test condition and control condition. The test and control conditions should be different enough from each other to allow stimulus control to be established more easily. This is a middle ground between a multi-element design and reversal design. A brief functional analysis is a bit of a last resort if assessment time is extremely limited. In this case, you would run each condition of a functional analysis only once to start. If you get differentiated responding, that is, if the target behavior occurs at a much higher rate in one condition relative to all other conditions, you would then ideally run that one condition again in order to get replication. Showing a functional relation is still important. Note that Iwata and Dozier have included a treatment probe on this graph. Obviously, when you implement an intervention based on the result of any analysis, you would need to continue to collect data to ensure that your intervention is actually effective, and thus that your hypothesis about the function was actually correct. If assessment time is limited because the target behavior is exceptionally dangerous, you could also combine this type of functional analysis with a latency-based analysis, to be discussed shortly. A single function test is similar to what was suggested by Hanley in previous week's readings. In this case, if you're fairly confident in a hypothesis of the function of a behavior based on indirect and direct assessment results, including conditional probability analysis, you could use a single test condition alternated with a control condition in order to confirm that hypothesis. This is another time saver. It's not ideal, since a behavior may have multiple functions, and your indirect and direct assessments may have missed that. It's also, of course, possible with any of these brief analyses that you simply won't get differentiated results. In those cases, you must then move on to a more thorough analysis. An extended alone series of sessions is used when you suspect that the behavior is maintained by automatic reinforcement. This is often actually used following a full functional analysis in which you see undifferentiated results. If the behavior is truly maintained by automatic reinforcement, you would see continued high rates of behavior in the back-to-back alone conditions, as indicated by the maintenance line on this graph. If the behavior occurred during the alone condition of the full functional analysis only because it carried over from other conditions, you should see the behavior extinguish during the back-to-back alone conditions, as indicated by the extinction line on this graph. As mentioned earlier, latency-based functional analyses are useful if the behavior you wish to intervene upon is particularly dangerous. In this case, rather than allowing the behavior to repeatedly occur and measuring its rate, you can simply measure the time that passes until the first instance of the behavior occurs in each condition. You could even block it from occurring once it begins if you wish to completely prevent it. We should assume that behavior that occurs with lower latency in a given condition is functionally related to the variables in that condition. That is, if behavior occurs immediately when I produce a demand, that more so suggests that it is evoked by those demands and thus maintained by escape from them. If behavior occurs only after several minutes of attention deprivation, if at all, there's less evidence that it's evoked by that attention deprivation. However, keep in mind that it might just take that much attention deprivation to evoke the behavior. You should always compare the results in each condition to those of other conditions. Graphed here, we see a typical multi-element design. The only difference is that latency is graphed along the y-axis instead of rate. However, this measurement can be combined with any of the variations on functional analyses discussed in this module. Finally, the authors discussed the trial-based functional analysis covered in the article by Bloom et al. During this module. The graph presented here displays the percentage of test and control trials in which the target behavior occurred overall. Bloom et al. Graphed the results the same way, since they used partial interval recording. You absolutely could measure and graph rate of responding as well, however. In summary, these are the reasons why you might wish to adapt functional analysis methodology. Limited assessment time, potentially dangerous behavior, limited control over environmental conditions, or undifferentiated results during your initial full functional analysis. In this module, we covered many ways in which you could accomplish this adaptation. During the next module, we'll talk about specific manipulations to the variables in each test condition of a functional analysis that you might make based on your hypotheses about the function of the behavior or the topography of the behavior. Always keep in mind these objectives from the BACB task list. As a behavior analyst, you must be able to design and implement individualized behavioral assessment procedures, as well as design and implement the full range of functional assessment procedures.